In this video, I am going to talk about LeetCode question number 53, maximum subarray. So, as per question, we have to find out the largest sum from the subarray. So, what is subarray? A subarray is contiguous, non-empty sequence of elements within an array. Means here we have minus 2, so it is a subarray. Minus 2 and 1, it is a subarray. Minus 2, 1, minus 3, it is a subarray. Like that we can form multiple arrays from this array. So all of those contiguous arrays are subarray of this particular array, and from that we have to find out largest sum. So here, as per explanation, the subarray 4 minus 1, 2 and 1 produce largest sum, that is 6. So we have to find out this, and this is kind of interviewer favorite question. Why it is favorite question? With this question, they will try to know your algorithms logic, plus they will evaluate your technical skills. So there are multiple things with this question one interviewer can get about you. So let's discuss about this question and how we should approach to solve this. And with this, we will discuss one algorithm called Kadane's algorithm to optimize this further. So first, our approach should be like writing the code in normal brute force way. So what will be brute force way? We have to find out like one element, and in that particular element we have to add all contiguous element. Next we have to go to this particular element, and then we have to find out, we have to add all other elements to this element. Next we have to go to this element, and we have to add other elements to this particular elements. So here we have to make use of two for loops. So we have minus 2, 1, minus 3, 4, minus 1, 2, 1, minus 5 and 4. We have to find out the largest sum, that is output is 6 here, and how we will proceed with this. So for that, basically we have to find out the sum first. So for that we have to iterate over each element. So let's say we have one for loop with int I equals to 0 and I less than nums dot length and I plus plus. So what it will do, it will go to the each element, and then here according to nums, means according to array, it will go up to the length, and then it will try to terminate that condition. Next we have to find the sum of all the elements from I to until the array of length. So what we can do, we can initialize the sum at 0, and then we can start the loop from j itself. Let's say j equals to I, means whatever the current index of I is, let's say I is here, so we will start adding elements from here itself. So let's say we have started from j itself, and j should be again up to the length, and then we can increment the value of j. Next we can add the all elements present at j, and then what we can do, we can simply check whether the current sum is greater than maximum number. So for that we have to initialize one more variable. So let's say we have initialized this variable max. So what we have to check? We have to check inside this for loop only that current sum is greater than max or not. If it is greater than max, then what we can do? We can update the max value from the sum, and simply we can return the max number. So let's try run this program. We have first I equals to 0, means we have let's say here I am writing I equals to what we have minus 2 at 0th index, and next we went inside this particular for loop. So here we are starting from ith index, means from 0th index. So first value will be minus 2 for j as well, and what we are doing, we are summing up with 0. So 0 plus minus 2 will be minus 2. So current value of sum will be minus 2, and we already initialize this variable max at 0. So next what we will do, we will go to the next element by doing this plus plus. So what we have to do, we have to like do sum. So here what we can do, update the sum with minus 2 plus 1. So we got 1. Is 1 greater than current max? Yes, it is greater than max. So we will update the value as 1. Same we will do add. Like that we will iterate over each element and try to find out the sum. And when the like maximum sum we will get, we will stop updating that value here, and simply at last we will return the max. So what is the complexity for this program? We are iterating over each element for first for loop. So we get order of n, and inside that we have one more for loop that is also going up to the n. So it is kind of n square. So it is not optimal solution, but yeah, we got the solution. So let's write down this program first. What we have to do, we have to first initialize the max. So let's say int max equal to 0. Next we have to take two for loops. So for int I equals to 0, I less than, we are getting numbers here from like main calling body of the main. So nums dot length, and then simply we can increment it. Next what we have to do, we have to go inside other loop to add all elements. So for that we need to open one more for loop, and there we can start from ith index itself, and next j will be less than nums dot length, and simply we will increment the j. Here we have to do the sum with all the current elements. So for that we have to define one more variable sum, and here simply we will do all the addition with the current sum. So sum plus equals to current number. So what we have? We have at jth index. Next, we have to check that current sum is greater than max or not. So we will check if sum is greater than max, then simply update the value of max from the value of sum, and outside this particular for loop we can return the max. So it should give the output as 6, 1 and 23. We are passing three conditions, and for all three conditions it should give output like this. Let's try running this program. We got output 6, 1 and 23. That is correct, but it is not a optimal solutions. To get the optimal solution, what we have to do? We have to follow one algorithm, Kadane's algorithm. According to Kadane's algorithm, we have to add elements until or unless the current sum is greater than or equal to 0. For the above example, let's say we have this one. Where it is? Let's say we have 5, 4, minus 1, 7, 8. So what we have to do? We have to add each element. 5 plus 4, that is 9. Again 5 plus 4 minus 1, like this we got 8. So here mostly like all the elements will be positive, so we will get at last 23. Let's try with first example. So there we will get like few negative values: minus 2, 1, minus 3, 4, minus 1, 2, 1, minus 5 and 4. So what it tells? It tells try to add value until or unless it is greater than 0 or it is equal to 0. So first value we have minus 2. Next, let's say this value is trying to add up. So currently what we have as sum, let's say we started from array of 0. So current value of sum will be minus 2. So next we will go like trying to iterate over each element. So first value will be minus 2, second value will be 1. So 1 is greater than equal to 0? No. So what we will do? We will simply start it from that positive value. Okay. Next we will go to the next element. Is our current sum is greater than or equal to 0? Yes. So it will add itself here. What we will get? Result will be minus 2. Next it will come here and it will check like current value of sum is greater than equal to 0? No. So it will simply update itself. Next it will go here and try to check whether current sum is greater than equal to 0. Yes. So it will add and we will get 3. Next it will come here, current value is greater than equal to 0. So it will add 3 plus 2. So what we have? 5. Next, and also parallelly we have to keep track of maximum. Whatever maximum is coming, we have to keep updating that maximum. So current maximum is 5. So we updated with 5. Next, 5 minus 5 is 0. So 0 won't be updated here. So we have 5. Next, what it will do? It will go to the next element 4 and try to add that. So 4 won't come under maximum, so it won't update with maximum. So let's try this program writing into our IDE. So for that I already written and submitted that program. First let's check submission output. So it beats most of the program like in 1 millisecond. So it is kind of most optimal solutions. So let's look into solution. Your last submission beats 99% of other submission runtime. So let me share with you. I have written this program. First int sum equal to first element of array, then max sum equal to first element of array, and then what I did, I iterated over each element for that particular nums, and I'm checking if sum greater than equal to 0, then I'm adding all values, else means sum is less, if sum is in negative values, so I'm simply updating the current num of I with previous sum, and then outside this particular comparison I am checking if sum greater than max sum, then max sum value will be updated by sum value, and then I will simply return the max sum. Let's rerun this program and check whether all the test cases is passing or not. So for first one we got output as 6. What we have input here? We have input same input 6, and then next one should be 1 and 23. So next input we got 1. For the third one we got 23, and you can see this beats all other solutions. So this is the most optimal solutions, and with this you got to know what is Kadane's algorithm as well. So yeah, that's all for this video. We'll meet in next video. Thanks for watching.